So thank you for coming to my talk. I will be speaking about migrating legacy data to your Django project. So, hi, my name is Adolfo Fitoria. I'm from Nicaragua, a country located in Central America, and yes, it's shaped like a Dorito. So that way you won't forget it never. So I work for a company called ePublishing. They are providers for software as a service solutions for news outlets and publications, and they are the owners now for Ellington. How many of you have heard about Ellington? Okay, so Ellington, the majority of the group that doesn't know it, is the first Django project ever. Basically, Ellington was the reason why Django was created. So Ellington is the CMS that powered the Lawrence Journal War back in the day, and it is still being maintained. It's alive. It's great. So that's my work currently. So let's get into it. Legacy data, what is it? So your applications, we always talk about legacy code, about COBOL and the Y2K bug, about all this Fortran code. But we also have to talk about legacy data. It's the data that comes from all old times. Like humans, we have been doing data since we have been talking and speaking. So back in the day, we draw into caves. Then we got that into paper. Then we got into computers, and we got it into magnetic tapes and all these old storages. Then we got into diskettes and zip drives. Anybody use zip drives in this room? OK, we are all. and also disk drives and cloud and everything that you can put data on. So, but in your Django apps, it's basically two things: your database and your media files or user uploads. Django is awesome. That's the reason why we're here. And SpecDB, this management command that comes with the framework, takes care of creating models.py of a legacy database. SpecDB has many options. You can just inspect one specific table, but in this case, for this talk, I will be doing a migration from WordPress to Django. So I wanted to get the whole WordPress database that is small enough so we can digest it in this talk. And it's a good example of what we are going to do in the future. So SpecDB is great, but it's not super magic. It's not fully magic. Sometimes it fails when you have a database that has a field that is not supported by the Django ORM. In that case, Django puts a text field, and it leaves a comment that says, hey, we cannot guess this field. So come back again and make it better. You can implement your own field class. So it works great. Django ORM needs a primary key. It's a rule, and we cannot avoid it. Sometimes we have old legacy data designed by people that maybe didn't need a primary key, so we have to either or add one explicitly, or see if there is a primary key on the table and it's not correctly indicated in the table structure. This happens a lot with WordPress. Within all versions of WordPress, you have all the tables. They didn't have any primary keys. And even to this day, they have primary keys, but they don't have relationships between tables. Everything goes to a single app. You can then split it manually. You cannot work with database schemas. It tries to guess it, but it's not perfect. So you have to manually add the DB table trick that we saw last day with the first talk by Tim Allen. Legacy data has surprises. You will have stuff that won't validate to your new schema or to your new database, so you have to work a bit and do some database massage, as I would call it. And not all DB engines work the same way. So some field lengths varies between the engine type, so you have to adapt to that. So how do we do this? We can take advantage of Django multiple database support. Basically, the first step is to add a new database that is our legacy database. We point it to the right hostname and driver and everything, and we have our default database that is our target database. Then what I usually do is start a new app, empty app called legacy. Then I add it to the settings.py in the install app settings. And then there's something very important to do. At least I like to do a legacy router. Basically, what I say that if the app name is legacy, use the legacy database. If the app name is not legacy, use the default database. So in that way, we can save a little bit of typing. Instead of doing model.objects, parentheses using equals legacy, we can just do model.objects.filter or whatever we can do. We add that router to the settings.py, and then we start the magic. We start to do the manage.py inspect db database equals legacy, and then with the greater than sign, you can redirect that output to a the models.py file. So you'll have something like this. This is the structure for just one table, but normally the models.py is huge depending on the database size. And then you have to investigate and look how the data is in your legacy database. You can use many tools for this, wherever you feel comfortable. I tend to use the SQL terminal. Also, by reading the models.py file, it's a great tool. But we have something, a third-party package called Django Extensions that has a function called graph models that is a management command that produces this beautiful schema, relational schemas in a picture. So you can print it out and have it with you as a cheat sheet. So you can have it always there. Now to work. So the approach that I take is to create management commands for each use case. And then I work from the less related model to the most related model. What I mean by this is that the less related model is the one that doesn't have dependencies on other tables. So in this case, for WordPress, that would be a category model that everybody depends on that model, but that model doesn't depend on anyone. And then you're going to build up from the top to bottom the dependencies of each model. And this graph model command helps a lot because, well, in this case, it doesn't have any errors because WordPress doesn't have relationships. But if the database has foreign keys, you will see the relationship between each table, so you can know each dependency that it has. So my application is very simple. Just for demonstration, it has two models, one called category model. It has just the name. And the second one is a post model. It has a title, a body, a photo, that is an image field, pub date, and category. Then we start with the model that has less relationships. As we saw, category doesn't relate to anything, and it's called by the post. So we cannot start by the post. We have to start by the category. So I don't know if you can see it right in the back, but I can make it bigger. So basically, it's a management command. In the handle function, you add the query set that you want to import. In this case, WordPress stores categories in a table called WP terms. And for each term from WordPress, I create a category on my application. So that's the translation part. that you do. Then the second part should be just importing the post. In this, I'll just query the target table, that is the WP post. I do a filter because in WordPress, the post table also contains images, draft, also contains pages, attachments, and many stuff, not just post. So I filter by post type post. Then I do a for loop and insert the data from the WP post to my post model that is a title, body, and pub date. For categories, we get the category by querying the WordPress database. In this case, it uses an intermediary table called term relationship. And then you have to query the WP terms table to get the right category from the database. It's always important in this case that you have to be prepared for cases like a post that doesn't have any relationship with categories because WordPress allows it. But in this case, you have to always add a good default that can be good for your application so it doesn't break. In this one, I'm not importing the images, but continuing with that, just guess that the first part is the same, and then I get the image. The images in WordPress are stored in the WP post table also with a post type called attachment, and then I get the image and save it into Django using the URL. Basically, the image in WordPress is the full path URL with domain and full file extensions. You have to do it this way to be able to respect your media with your file upload backend in Django. So if you're using S3 or file system, it will just use that, and you don't have to worry about special setup. And then you run these commands and wait, and wait, and wait, depending on the size of the database. I have done migrations for stuff that takes from 1 hour, in a good case, up to 8 hours with my computer being very hot in a way that you can cook something on the top of it. So let me just show you quickly how it looks. So this is my administration. It's empty right now, but for the legacy, it has post objects and user objects. This is the WordPress site. It's a basic site. And this is my Django site that is empty. Can you see this on the back? Okay. So we first import categories. Then you will see that on my admin side, you will have the two categories that are in my demo site. And then I can have posts. And then the posts with images, so they're there. So if I reload the site, you'll see the imported data in your Django application. So this is not enough. Getting back into the waiting icon, this is not enough because this is just a sample, and it was just not optimized enough. So we have to then optimize all the things. This was not very efficient, and we can make it better. So less queries mean more speed. You'll be reading thousands of data, depending on your database structure. You want to avoid queries in loops. So there are techniques basically to not having each loop for loop that we are going to do, making queries that can be cached or repeated. You can use caching. More importantly, when creating new models, each time you create, you call save, like in these cases, is a query, is a connection being opened. So you can use a method called bulk create that will group many models and just use one query to insert them all. You can also query just the field that you need. So in this case, I will just need it post title and body and category. And we don't have to query this whole field things like post name to ping it, post modifying, all that stuff. And you can use pagination. Why? When you have a table that is very large, when you do object.all, it takes a lot of memory to do all that serialization from SQL up to Django objects. So it's better to run some pagination, like saying, extract me 1,000 records each time instead of all the records at once. So your memory consumption is less, and the script runs faster. I did this error back in the day, and then I saw that when the time passed, the scripts were slower and slower, and my RAM was getting to 100% every time. So using pagination, it allows you to keep a decent RAM usage and also keeping a decent processor usage. You can see more on these advices on these two links in the bottom. I will provide the slide links at the end, so you can just click them. So we have the optimized version of both commands. So in this case, I have a dictionary called category cache that will save the ID of the category as a key, and the value of the dict will be the category object, so we can save it. Post data will be a list of post objects that will be used later in bulk create, and the only fields are the fields that we just care about the post table. In this case, just post title, post content, post date, and ID. We have a default category, and we have the new query set that is slightly different, just by adding only and the only fields that we need. In the loop, it will be almost the same, just that in this part, I will use the local caching of categories. Basically, if the key of the category ID is on the dictionary, I will just return that. And if it's not in the dictionary, I will query the database. So in this first part, we are avoiding queries in loops. We will have them, but it will be much less, because in this pattern of categories and post objects, categories can be a few, and the post objects will be hundreds or thousands. Then we have this postdata.append post. Basically, we add the post object to the list, and in the end, we just have a bulk create function that takes that list and do a save with just one query. This bulk create function has another parameter for the quantity of object that you want for each query. So it does some kind of pagination in the inserts. So you can say 100 objects at a time, and if you send it like 500, it will do 5 queries instead of just one. So this helps a lot also in performance. So in the past example, with this small data set, before the optimization, it uses 14 queries in the default database and 19 queries in the legacy database. And for the after example that is optimized, it uses 7 queries for the default database and 13 queries for the legacy database. So it's an improvement, at least for the default database, in 50%, and some percentage on the legacy. This will be quite different depending on your use case and your data structure. So in this case, it's really good, but maybe you cannot avoid much queries in your case. So there's another thing that you can do is that you can use this technique to migrate stuff from one database engine to another without doing any transformation. So just basically do a model.object.all and save it to your target database. So there's stuff that I didn't know that maybe you should know is that validating all the things before inserting it into your production database. The bulk create and also Django object.create methods do not apply any validation that are inside of the save method. So you want to have to take care of that beforehand. You have to also see if you really need all the data that is on your legacy database. In that case, you don't carry any data that is not clean or won't be used again. Also, in this case, you will have to clean data up. For instance, when migrating stuff like content sites, maybe some content has some tags that are not valid anymore, or that you don't want to include, or you want to clean some stuff. Like, for instance, if your content size has all YouTube embeds codes that won't work because YouTube started to use iframe embeds, you will have to transform those in your content before. Prepare for exceptions. They will happen. You don't know what the data looks like, so you have to take care of those exceptions on those cases. In my case, I once imported data from HTML files dating back to 1998. So in some cases, the files were empty, or they had inconsistencies on the markup, or they had basically trash, or they were hacked back in the day where defacing was popular. So all those cases you have to take care. This is not a work that will be super fast to do. It's fast to code it, but then in the testing phase, you will take some time to see that everything is OK. And this is not limited for database only. You can do this technique with CSV files, for HTML files. You can scrape a site that already exists and create a crawler to fetch the data. You can use, well, there's another case that I did in the past that a site uses Access as a database for production. So basically what we did is to export Access to XML, a query in Access to XML, and then create an importer for doing that. So please, if you still use Access as a production database, please try to migrate it and don't do it again. So the takeaways will be migrating data will be tricky, always. Nobody takes care about data a lot until you do these processes. And data can be dirty, can be incomplete. It will always be tricky. Django InspectDB helps a lot in the process, but it's not a perfect tool. It won't ever be because databases are really hard. Everything is a loop. And inside of a management command, you can take this approach, or you can use something like a normal Python script that calls Django. Less queries equals more speed in inserting and also reading. And every import case is unique. So that will be all from my side. Thank you very much for attending this talk, and I will take questions if you like. So, thank you.
Adolfo, thanks for the talk. What was the largest data set that you imported? How many rows?
Well, the largest one was this with files that I told you about,
Yeah.
from 98 to 2006. So it was around, without the dirty files, around 150,000
How
articles.
did you manage, like, because obviously you ran into dirty data and it would break, you'd throw an exception, not caught, because you're like, oh, didn't see that one coming. How did you roll back? How did you manage your rollback to, like, okay, I've already done this part. I don't want to touch these again. Get me to this point.
Yeah, basically, what I did in that case is I prepared the script to be incremental. So I printed out IDs. So when it broke, you can see the last ID that was inserted. So we can just create a filter from this point on. You can help in this case. But for files that are static, I also created like a small table, temporal table, that was storing what file was processed and what article was created from that file. So you can have control on where do you left or where do you broke the last time.
Thank you very much.
Any more questions? Well, Mr. Adolfo will be available in the hallway track if you had any longer questions. Let's give him another round of applause for the presentation.